Welcome back to another algebra skills practice, this time covering domain and range. The domain of a function is the set of all the possible values that we can input to the function. We can think of these as the x values that we're allowed to plug in. In many cases, this will be all real numbers. For example, in the case of polynomials, exponential functions, and certain trig functions like sine and cosine, we can plug in any number we want and get an output. But there are some specific instances where we can't plug in certain numbers. For example, if we have the function the square root of x, we know that we can only plug in non-negative numbers. That is, numbers have to be greater than or equal to 0, the inputs. For a function like 1 over x, or any rational function, we know that we can't divide by 0. X cannot equal 0. And for log of x, we can only plug in positive numbers. In this case, x is greater than 0. Anytime we're writing the domain of a function, we'll usually use our interval notation that we talked about in a previous algebra skills. So if it says find the domain of 4 minus 6 times the square root of x plus 7, we know that parts of this function, we can plug in whatever we want. There's no x there, and it's defined everywhere. But for another part of this function, we know that we have certain rules we have to follow. Specifically, we know that square roots, the stuff that goes into the square root, has to be greater than or equal to 0. And so if we look at the square root of x plus 7, that's really all we care about when finding the domain. We know that we require the stuff in the square root to be greater than or equal to 0. This is an easy enough inequality to solve. We can subtract 7 from both sides, and we get x is greater than or equal to negative 7, which we can write in interval notation as a square bracket, negative 7, going up to infinity. So we can plug in negative 7, negative 6, negative 5, all the way up to 0, any positive number, but nothing below negative 7. If we plug in negative 7.1 or negative 8 or negative 10, this function is undefined. Let's try this one. This is a rational function, 2x plus 7 over 3x minus 1. We know that for most values of x, we can plug in any value of x, and this is fine, except for the fact that this is a rational function, and we know that we can't divide by 0. So if we're looking for the domain of the function, we can plug in anything we want, except for something that would cause 3x minus 1 to equal 0. If we solve this equation, add 1 to both sides, divide by 3, we know that x equals 1/3 is the only point we can't include. So in general, we could write that this is all real numbers other than 1/3, or using interval notation, we could say that we're going from negative infinity up to 1/3 with a round bracket, and then also from 1/3 up to positive infinity, also with round brackets, and then this union symbol ties them both together. Notice that since neither of these brackets are square, 1/3 is not included in the domain. Last one we'll look at is 2 plus 6 log 6 minus x. Again, the 2 doesn't really change anything with our domain, but the logarithm has restrictions in that the input to the logarithm has to be greater than 0. So we could write 6 minus x is greater than 0. We could add x to both sides if we wanted, getting 6 is greater than x. Or equivalently, we could write x is less than 6. Once again, in interval notation, that is going from negative infinity up to 6 with round brackets for both of them. If we tried to plug in 6.1 or 7 or 10, this function would be undefined. So the domain is from minus infinity up to 6.